Hi everyone, and welcome back to another exciting build-along video. In this video we will be displaying a new tension system that will take your actuators to new lengths. As always, we will take you through a step-by-step assembly of this new linear actuator and have you up and running in no time. Please feel free to leave comments below on this new design and make sure to subscribe to our channel so you can be notified of new releases. Here's a quick overview of the assembly and a display of the simplicity of this build. Now, without further ado, let's go ahead and get started on this build. On this first step, we're going to focus on assembling our wheels. You should have 4 extreme wheel kits. Inside of each bag, you'll see the contents, which is going to include 2 bearings, 2 precision shims, and a nylon hex nut. So you can see we have the extreme wheel shell, our 2 open bilge bearings, the nylon hex nut, and 2 precision shims. So in order to assemble this wheel, it's a simple process. You're going to pop in one of the bearings to the outer face of the shell. You're going to add one of your precision shims here in the middle, and you're going to sandwich that in with your additional bearing. These additional components, the precision shim and nylon hex nut, will be used later in the assembly, so we can just put these to the side. And let's go ahead and assemble these additional 3 wheels. Now that we have our 4 wheels assembled, let's go ahead and move on to the next step. On this next step, we're going to be focusing on attaching our nut blocks to our extra large gantry plate. And this is going to build up our carriage for this long actuator. So in this step, we'll need our extra large gantry plate. We'll need 2 of our nut blocks, 4 M5 20mm screws, 4 3mm aluminum spacers, and 4 nylon hex nuts. Now the 4 nylon hex nuts, 2 comes with each one of the nut blocks, so you'll simply take those out of the kit and use those for this assembly. So the first thing we're going to pay attention to is the hole orientation for the plate. As you can see, we have a larger set of holes on the right side of the gantry plate if you're holding it like I am. And then you'll see that we have a smaller set of holes here on the left side. So the larger set's going to be used for the eccentric spacers, and this will be for the wheel assembly. And then the left side will be used for the fixed wheels, which is going to use the aluminum spacers. Now, the reason I'm mentioning this now is the nut blocks need to be placed in these 2 outer holes. So we want to make sure that our gantry plate is oriented to where our eccentrics are going to be on one side and our fixed wheels are going to be on the opposite. So these 2 holes, we're going to go ahead and insert our M5 20mm screws. And with the screws erect, I'm going to add my 3mm aluminum spacers to each screw. And taking the nut blocks, I'm going to make sure that the hex side here is facing upright, and that's for our nylon hex nuts. And lastly, I'm going to add the nylon hex nuts to each screw. Now, sliding the plate off the table, I'm going to keep the screws in place and just work on one block at a time. Now, when I'm tightening these down, I'm simply going to leave a little room. So you see how my nut blocks are mobile? That's so it's easier to line up the lead screw to the block, so you're going to feed it through one and then the next on the opposite side. And then from there we'll be able to tighten down each screw once that lead screw is set in position. Just really helps with the assembly. So now that we have that complete, let's go ahead and move on to the next step. On this next step, we're going to be assembling our wheels to our extra large gantry plate, and this is going to create our gantry cart for our actuator. So taking our extra large gantry plate, I want to focus on the difference between the hole size on each side. Remember, we have the large side and the smaller side. One's for the fixed wheels, the others are for the eccentrics. In this assembly, we're going to need our extra large plate assembly that we have thus far. 4 of our extreme V wheels, 4 precision shims, 4 nylon hex nuts, 2 6mm aluminum spacers, 2 6mm eccentric spacers, and 4 27mm M5 screws. In addition to that, I'm using my ball driver, open-bilt's ball driver. It's 3mm, and my open-bilt spanner wrench. Now to start this assembly off, first I'm going to insert screws onto each one of these corners. So taking the 27mm screws, let's go ahead and insert those now. Okay, with a plate on its back and my screws erect here, I'm going to add my 6mm aluminum spacers first, once again to the smaller holes on this side of the extra large gantry plate. And then I'm going to add precision shims to each screw and an extreme wheel to each screw. Sometimes you'll find that you have a precision shim that is wedged to the side of the bearing. The simplest way to cure that is to take a ball driver and just sift it into place. Taking the nylon hex nuts, I'm going to thread those onto each wheel. Okay, I'm going to rotate the plate so we can focus on the eccentric side next. This is going to receive our 6mm eccentric spacers. And one thing to pay attention to with the eccentric spacer is you're going to see this 6mm stamped end. Now this indicates the fully open position of the eccentric. So wherever this rotation is going to indicate how much friction or preload that you'll have on the rail with the wheels. So you can mark these ends with a permanent marker so it's easier to see. With the 6mm side stamped, I can see it pretty well, so I'll know my adjustments. And you can see that we have an off-center hole here, so it works as a cam. So when you make that adjustment, it's going to tighten or loosen those wheels to the rail. So the 6mm stamped side needs to be facing away from our fixed wheels. So each one that I see that is stamped is going to be facing away from the fixed wheels. And then I'll add our precision shims next, and our extreme V wheels on top of the shims. Next, I'm going to add the nylon hex nuts. And from there, I'll use the spanner wrench and my 3mm ball driver. And we're going to tighten these wheels. So now that we have our extra large gantry cart assembled, let's go ahead and move on to the next step. On this next step, we're going to be focusing on our eccentric adjustment for our 1500mm C-beam rail. So for this linear actuator in particular, we're using the longer rail. And this is really a simple process. I'm going to try to explain it as best as possible. The eccentric adjustment seems to throw people off sometimes. But what we have here is our fully open position. You can actually see that the screws are closest to this outer lip here on the diameter of this hole. So that's exactly what we want. That means it's a fully open position. So when we slide this onto the rail, you're going to see a lot of play, but it's going to just slide onto the rail very easily. So taking my gantry cart, once again, you'll see that we have the fixed wheels on one side, eccentrics on the other. This is very important because it's going to stabilize your plate once you adjust your eccentrics. If you had it on the opposite side, it's just not going to fit. So that being said, we're just going to slide the wheels onto the rail. And to my surprise, that actually fit pretty tight. So even at a fully open position, we're not going to have a whole lot of adjustment to make on this gantry cart. But if I hold down the rail and try to move the gantry cart, I'm going to feel some movement. Now it's slight, it's not a big deal, but we want this to be completely tight to the rail. We want smooth linear movement. So taking our spanner wrench, my eccentrics are both on this side. What I'm going to do is rotate these in the same direction, just a slight adjustment. And what I like to do is just feel the wheel. And as I'm trying to move the wheel, it's trying to move the gantry cart. So same with the opposite side. You should have that friction on the rail, which is known as preload. So on this second wheel, we're going to do the same exact thing, same adjustment, same rotation. And as I'm adjusting, you can actually feel the tension being placed on the wheel. So when I get to a point where I feel like it's just really tight with two fingers, I'm going to double check that wheel, make sure the friction's on the rail, and that is exactly what you should see. So if I were to try to move this gantry cart, it's trying to move the C-beam. So that's exactly what we want there. And that's a simple adjustment. Let's go ahead and move on to the next step. On this next step, we're going to be attaching our lead screw to our extra large carriage plate. So in this assembly, we're just going to need the lead screw and our assembly that we have so far. This lead screw measures out at 1540 millimeters. The 40 millimeters is basically for the additional components that will be added in the tension system that is going to be applied to this linear actuator. So basically we're going to have 20 millimeters on each side of the actuator that's going to accept those additional components. So to get started here, we're going to feed the lead screw through one side of the nut block, and then we're going to feed into the next. And one thing that we need to remember is to tighten down each one of these screws on our nut blocks once we get the lead screw through. So let's go ahead and start over here on the left side. Simply going to feed this into that nut block by rotating to the right. And once you get to the second nut block, what I like to do is just position my finger on this side so I can adjust the orientation. And I'm going to continue to rotate that to the right until I see that lead screw protruding past. Okay, now that I have the lead screw past my nut block quite a bit, I'm not going to feed it all the way completely through the nut blocks. So if I pull back, you can see that I have a good amount of the lead screw through the nut blocks. But what you can do is just push the lead screw down. So what we're looking for is 20 millimeters on each side of the actuator. So as you can see here on the right side of the actuator, I have a good 20 millimeters sticking past the end of the C-beam. Now I have the same thing on the opposite side. And that's all that we're looking for there. Adjustments can be made once we're adding the additional components to the lead screw. So don't concern yourself with the exact measurement. We'll get into that on the next step. So let's go ahead and move on to the next step. Okay, on this next step, we're going to be focusing on attaching our end plate to one side of the actuator. This end plate in particular is going to receive our flexible coupling, which will then attach to our motor on a later step. In this assembly, we'll need one of our open builds motor mounting end plates. We'll need 4 M5 15mm screws, our 1/4 inch flexible coupling, and our thrust bearing set, which will be a 3-part assembly. And then in addition to that, I'll have my ball drivers here, 3 millimeters, a 2.5, and a 2 millimeter. So on the end of the actuator, I'm going to take my open builds motor mounting end plate, and I'm going to slide that into place to fit in line with the tapped holes on the C-beam. And I'm going to use my 4 M5 15mm screws and 3 millimeter ball driver to attach the plate to the C-beam. Okay, once the screws are attached, I'm going to add my flange bearing next. And the flange bearing will have this outer rim, which is going to fit on the outside of the plate. Next, I'm going to add my thrust bearing, which is the 3-part assembly. For this, you'll see the bearings here are going to fit inside the recessed hole of the outer shell. And you're going to sandwich that together. Add that to the lead screw. And following that, we'll take our 1/4 inch flexible coupling, which the 1/4 inch bore is going to be smaller than the 8 millimeter side. The 8 millimeter side is what we're going to be attaching to the lead screw. The 1/4 inch side will attach to our motor shaft. Now, one thing to pay attention to when adding this flexible coupling to the lead screw is we want to make sure that we have our set screws, not the clamping side, but the set screws facing upright. So when we adjust the motor orientation, we can simply slide it in and lock that into the flat portion of the motor shaft, which we'll get into on later steps. So I'm going to take the 8 mil side and attach it to the lead screw. Using my 2 millimeter ball driver, I'm going to tighten down that set screw. rotate, and tighten down the clamping side of the flexible coupling. Once again, I'm going to rotate this to where my set screw is facing upright, and that completes this step. So let's go ahead and move forward. On this next step, we're going to be assembling the opposite side of this linear actuator. So we're using one more of our Open Builds motor mounting end plates, 4 of our M5 15mm screws, our thrust bearing set, a tensioning nut, one of our flange bearings, and of course my ball driver set here. So I have a 3mm ball driver and a 2.5 for this assembly. Okay, starting with the end plate first, just like we did the opposite side, we're going to attach that to the C-beam using our M5 15mm screws. Okay, so once you have the screws attached to your C-beam, next we're going to take our flange bearing and place that into the open slot here on the end plate. Next we'll take the thrust bearing. Once again, same configuration. We're simply sandwiching this into the 3-part assembly. Attach that to the lead screw. And following that, we'll be adding our tensioning nut. One thing that we need to do first before we add this is loosen this set screw. And I do that with a 2.5mm. And what I like to do is place this nut to where that set screw is facing up, because when we come back later in this assembly, we're going to add tension to this nut, and we need to make sure that we can lock that set screw into place. So I'm just going to rotate that to where it's facing upright. I'm just going to lock that down for the time being. And let's go ahead and move on to the next step. On this next step, we're going to be attaching our NEMA 23 stepper motor to the opposite end of this actuator, the one that has the flexible coupling on that side. In this step, we'll need our stepper motor, 4 40mm aluminum spacers, 4 M5 50mm screws, and of course my ball driver set. I've got a 3mm, 2.5, and 2mm. Okay, so the first thing that I'm going to do is take my NEMA 23 stepper motor, and I want to show you the flat portion of the motor shaft. So as you can see here, the flat portion of the motor shaft, and then you have the rounded rest of the shaft. So this flat portion of the motor shaft is going to attach to our flexible coupling and lock in with this set screw. So taking our M5 50mm screws, I'm going to go ahead and run these through each side of the motor. And you can see I have the orientation of my motor with the wires hanging to the right, and that's just for easy access to run this actuator. So next I'm going to add 40mm aluminum spacers to each screw. And I'm going to lock it onto the end plate. Taking my 3mm ball driver, I'm going to go ahead and attach each screw to this end plate. Okay, now that I have all of my screws locked into the end plate, we're going to turn our attention here to the flexible coupling. Now here on the flexible coupling, we just want to make sure once again that flat portion of the motor shaft is inserted and it's aligned with that set screw. From there I'm going to take my 2mm ball driver and I'm going to go ahead and tighten that set screw down onto the motor shaft. Once I rotate this, I'm going to go ahead and tighten down the clamping portion of this flexible coupling. And now that we have our flexible coupling attached, so let's go ahead and move on to the way that we're going to tension this whole system. Okay, so on this next step, we are going to attach our black box to our motor. And of course, the power supply is going to be powering our black box. And what we have is one motor attached. I have it attached to my Z-axis. That way we can control that axis in particular. If you want, you can add it to any one of these axes. It's completely up to you. I'm using the Z in this video. And on our laptop, we are connected to Open Builds Control. So what we're going to do is connect our control software to our black box, and that's going to put it into an idle state. And that's basically going to lock your motor so we can add tension to this opposite side of the actuator. So let's go ahead and turn our attention over to the tensioning nut side of the linear actuator. Now on this side of the actuator, what I'm going to use for this is a pair of pliers. You can use vice grips if need be, but we're simply going to add tension to this nut, so we need to loosen the set screw on top. And once we loosen that set screw, I'm going to come in here with my pliers. I'm going to grab it and start to rotate to the right. Now you're going to feel tension being placed onto this tensioning nut. One thing that we're looking for is the proper amount of tension. So essentially, if you rotate too much to the right, what you're going to hear is a misstep on your stepper motor, just like that. So now at that point, I've got to reassess my tension onto my nut. So I'm going to bring my pliers back in, and I'm going to rotate to where I'm on the cusp of missing a step, and I'm going to tighten that set screw down. And at that point, you have put enough tension onto that lead screw for a 1500mm length. So now we can run these longer lengths with lead screws without having that whip that you would see in a compression system. So now that we have that complete, let's see how it runs.
No excessive whip, and this tension system is running like a champ. Thanks for tuning in, and make sure to subscribe to our channel and stay tuned for future videos.